Now let's turn to two other forms of energy that humans have long used, wind power and water power. In the 12th century and 13th century, a kind of mechanical revolution took place. It wasn't the full mature machine revolution of the 19th century industrial revolution, but we could call it an early or even a preliminary mechanical revolution. And the key inventions were here the water wheels and the windmill. Um, a water wheel produces about 2 to 5 horsepower, and a windmill about 5 to 10 horsepower. The picture is too fancy, isn't it? So, so then how much horsepower does a single car have today? A modern Korean SUV like the Sorento has over 280 horsepower, an enormous amount of power compared to those earlier machines. Even the smallest compact cars like Marine, Kia Marine, have around 78 horsepower. 78. And my own small SUV has 139, 139 horsepower. So compared to that, it's hard to call war wheels or windmills a revolution in terms of raw power output. And yet, it's just as hard to deny that they represented a major turning point in how humans use tools and harnessed energy. The earliest water wheel worked like a kind of turbine, a horizontal wheel that spun flat. It was a step up from having people like slaves or animals do the turning. And because now you could rely on water, which it was easier and could run continuously. But the truly revolutionary and even brilliant innovation was turning the wheel from a horizontal position into a vertical one. Roman engineers in the first century accomplished this. Um, uh, yeah, the first century BC. As you can see in the picture, uh, once the water wheel was set upright, it became possible to make much better use of the force of flowing water. And with the vertical motion, you could now convert it into horizontal motion, like these wheels making the power from the vertical one into horizontal one, and vice versa, just like this illustration. And you know what? It is made from wood, right? Yes, wood wheel. And this picture also shows the like converting the the flowing water and the water wheel into um like the arise the power, this arise the power in making it into a vertical one. And this is a perfect representation of and transformation of the vertical movement into of the wheel into horizontal movement of the milestone. And this is like one of the like Korean traditional war wheel works like this. Yeah, I remember I saw this in like the traditional museum or things like that. This picture shows a like uh, when you can probably figure out how it works just by looking at it. As the water runs down like on down the wheel, the X rotates which moves the hammer. Yeah, this one hammer beam up and down, and the pounding hammer crushes the grain. You put grains right here, and this gadget, this system makes the vertical movements into or like horizontal one, and it makes uh, the hammer up and down. If we use the same mechanism in the way was shown on the right here, it becomes a kind of saw, right? So this is also shows the transformation of the vertical power into like horizontal one. And, and this same system, the same system can also be used in a blacksmith forge or in like a silver mine. Like this picture is from the textbook, the brothers book, and it shows the diverse usage of the war wheel, and and war wheels didn't remain limited to simply grinding grain, and they you see is expanded into many different fields like blacksmithing, hammer, mine host, pumps, and more. The picture here shows a 15th century silver mine. On the right, you can see a machine that lifts heavy rolls using ropes or chains. And this is called a hoist. In mines, people, tools, and supplies could be lowered and raised using this kind of mechanism. Um, the first breakthrough was setting the water wheel upright, but the second major development was this. Water wheels moved into urban areas, like the picture shows. Um, and as noted earlier, we have to be careful about cause and effect here. Water wheels didn't move into cities because someone intentionally relocated them. They moved because the need and demand in cities were far greater than in rural areas. So at first, warriors were located along rivers and the countryside and were used mainly to grind grain for manorial estates. But once economies moved beyond the manorial system into market exchanges economy, goods needed to be collected, processed, and redistributed. And because exchange economies operate for the benefits of cities, war wheels gradually became more and more common in urban centers. So a wide variety of war wheels like this installation began to appear. They effectively became the standard energy infrastructure of pre-industrial society. People even recorded the number of warriors to indicate the water flow of a river, and in some cases used war wheel counts to estimate population. Um, a good example of how widespread they have become is found in the Doomsday Book, the 11th century English census. um, along the Severn and south of the Trent, the river, in about 3,000 villages, there were 5,624 water meters. which means on average each village have about 1 or 2 mills, close to two, right? And across Europe as a whole, before the Industrial Revolution, there were about 500,000 to 600,000 water wheels, producing the equivalent of 1.5 million to 3 million horsepower. Between the 12th century and 18th century, their number doubled. So, was this a revolution? Compared with the dramatic developments that came later, it took it might look small, but we shouldn't dismiss how significant it was for its own time. Now let's take a look at windmills, the machines that harness the wind power. Some people trace the origin of the windmill to China, but it's more likely that it began in highlands of Tibet or Iran. Brodel doesn't really give concrete evidence for this claim, though. After the seventh century, Iranian windmills also shifted from horizontal wheels to vertical ones, and even though they required more maintenance, their uses expanded and they became increasingly widespread. And after that period, the main function of Dutch windmills was to keep rows of water lifting buckets moving, um, so that water could be continuously pumped out of the lowlands into drained into the canals. This is called in Dutch Wipmolen. The word whip meaning the seesaw, like seesaw. Do you know what it is, right? And molen meaning windmill. So, like using the power of wind is pumps up the water from the lowland into the sea or the canals. And this picture shows this system and you know what the we this um this region is called lowlands, right? Meaning that the many parts of the this country is lower than the sea level. So, but anyway, these windmills always are working uh, the pumping out the water in the lowlands. So, the Dutch guys uh make these lowlands into like the normal lands. And a ship's sail. Sails are another example of harnessing wind power as an energy source. And then during this period, the size of ships increased dramatically. In the 16th century Europe, the total merchant fleet capacity was about 600,000 to 700,000 tons. But but by the 18th century, it had grown to 8,372,000 tons, a five-fold increase in just 2 centuries. If we assume each ship made about 3 voyages per year, that means roughly 10 million tons of cargo were being transported annually. Yeah, like this that's on the scale of what a major modern port can handle today. This is Busan port. The exact numbers are hard to calculate precisely, but the overall growth is unmistakable. Um, yeah. Lastly, let's take a look at um the the one of the most important one. And yeah, so compared to with all the energy sources we've looked at so far, what do you think was the most important and most widely used sources of energy in everyday life before the 18th century? Yeah, that is wood and coal. Um, and in the 19th century, coal began to be used more and more. So in that sense, it's not an exaggeration to say that human civilization before the 18th century was essentially a wood-based civilization. 19th century, there's some like coal civilization or things like that. But anyway, it is important to see that wood is basically the most important one. Yeah. Up until the 18th century, wood was the primary material for most industries, from basic cooking and heating to houses, ships, and even the gears inside war wheels and windmills. Almost everything was made of wood. Of course, there was a parts that required metal, but iron was always used sparingly, only where absolutely necessary. Because wood was used so extensively, many regions eventually faced shortages and even forest depletion. And it was at the moment that at that moment the coal entered the picture. The coal burned harder than wood or charcoal, and its heat lasted much longer. That's why we could sometimes call this a shift from wood to coal. We call the coal revolution. 1 ton of coal produced as much energy as 2 tons of wood. But that doesn't mean demand for wood simply disappeared. Even in the United States, coal didn't really overtake wood until 1887, toward the end of this 19th century. So when we enter the 20th century, it's not that coal became important and wood suddenly stopped mattering. Coal grew in importance, yes, but wood remained an important energy source. Its share simply became smaller. Even today, if we look at everyday life, our dependence on wood is still quite visible, right? Coal's truly decisive role, however, was in enabling the large-scale production of iron, and that development is what pushed Britain toward modernization and the Industrial Revolution. Right? And so now the real hero of the modern age and the Industrial Revolution finally steps onto stage. There's an there's iron. All right, let's take a break. I come back soon.